And in the final video in this series, we talk about vacuum. We talk about some basics of vacuum. We talk about some vacuum practices for larger jobs. So again, we're talking to market refrigeration technicians here. There are some special considerations, but the basics are still the same. We need to make sure the system is clean, dry, and tight, and vacuum is a huge part of that. Big thanks to Matthew Taylor for helping us create and present this excellent training class.
So we complete our nitrogen test. What are we going to do? We're going to vent our nitrogen to atmosphere, and we're going to begin our evacuation process. That's next, okay? So why are we doing that? Well, a lot of guys use our vacuum as our leak check, right? Well, that's what our pressurization really was about. We can use vacuum for that, but the real purpose of our vacuum is to pull that moisture and air and non-condensables, non-refrigerants out of our system. That's really the purpose, is to clean the system. So how do we do that? We're going to pull down into the deepest micron we can so that we're going to cause that water vapor to boil, and then it's going to be gas, and we're going to remove all the gas that we can. Now, Brian's been talking about the old guy a lot, and I'm thinking in my head, that's my dad, right? It's possible, might be me a little bit, right? So I'm getting a little older, and I'm noticing that the way we did this years ago and versus what we're doing today are very different. One of the reasons for that is our vacuum pumps are vastly superior. Our micron gauges are vastly superior. What we've learned about how all this works is vastly superior. And as we've said before, it really didn't matter quite as much as it does today. So today with modern POEs, modern electronic valves, all that stuff, this is far more critical than it's ever been. So if you got the old guy who's been telling you, yeah, just give it a little burp of refrigerant there and you're all set, that probably was true in 1980, right? 1980 was a long time ago. So we're not going to do that. We're going to learn the proper process to pull a good hard vacuum. And we are going to do that over here as well. So I won't go all the way through that. But I will tell you, one of the things is we want to start with a good vacuum pump. And I told you, modern vacuum pumps are better than mine, right? I've got one in my house that's probably 30 years old that just won't touch this, won't even come close to this. If I get 500 microns out of that, it's, I pat it on the back. It did a good day, right? 50 is the standard today, right? So if I hook up my micron gauge to my vacuum pump with nothing else, I should be able to achieve about 50. That's really, really low. That's extreme, all right? So know that. Second thing that we've learned is those 1/4-inch hoses, they'll do it eventually. Eventually 8 hours, versus 30 minutes kind of thing. So we've learned the diameter really matters, right? So, the new standard today, I'd say, is 3/8, 1/2 inch if you can use it, but 1/4 inch is just not going to cut it. So that's just one of those best practices to get it used to. The next one is riding that vacuum pump around on your truck. All right, see guys do this all the time. They leave the cap open, they leave the valve open. You're going to fill that vacuum pump with moisture while that's happening, right? Oops. So if you're going for that old 500 from 1980, you're going to make it, but you're not going to get much below that. So just be careful of that. All right. And then the last thing is the ballast. And I could probably talk 20, 30 minutes about why we use a ballast and the advantages of that. But just know that that's a thing, and if you don't know a lot about it, definitely talk to some folks that do. One of the big things we need to know is that we should be using our ballast to keep our moisture from condensing in our oil while we've got moisture, right? So we'll close that off and we'll use it to pull on down once we've boiled some water out, and it's a minor amount, okay? And just for fun, we're going to inject a little bit of water into one of our pipes here and then pull a vacuum on it so we can actually boil that out. It'll be kind of neat to watch. And that brings up my oil. So the next bit here is vacuum pump oil is probably the #1 biggest thing that, as a service, on the service side, I can do to control how well my vacuum pump works. When my vacuum pump oil is crap, I'm just not going to pull a very good vacuum. Not only am I destroying my pump slowly, but it's just not going to do a good job, right? So good practice on a giant supermarket, we're pulling a huge vacuum, something like that. We're going to change oil during that vacuum several times. When we get towards the very end and we're trying to get that really, really deep vacuum, we're going to start that segment with clean oil. We just pretty much have to. Okay, so some other best practices on things that we've learned over the years. My dad would not have told me this, right? But I'm probably not going to use my manifold set, my gauge set, while I'm doing this. Could I? Well, if it was all tight and it was all in great shape, probably. But the new standard today really is the core removal tool. If we think about that for a minute, pulling through a Schrader core is really magnificently slow. It will achieve it once again eventually, right? But we've learned that pulling those cores out of there massively improves our speed. Well, we're going to use that same tool now because modern tool removal tools are rated for vacuums, deep vacuums, probably better than my manifold set, honestly. So instead of hooking up my manifold to control my valves, I'm going to use my core removal tool. I am going to pull the cores, and I'm going to use that valve to control. Right, so that's a huge change, right? We mentioned the 3/8 hoses, so I'm going to go with a larger hose to my vacuum pump. I'm also going to set up my micron gauge as far away from my pump as possible. Now, as a technician, it kind of crushes your ego. When you flip that switch, it's great to watch that pressure just drop right on down because it's right there at your vacuum pump. But the reality is that massive system, and the bigger the system is, the more dramatic this effect will be. I got to move it to the farthest away point as I can from that vacuum pump to get a true reading on what's going on in that system. I was talking to Nathan a little earlier today, and he was talking about sometimes 2 or 3 hours after I've turned off my vacuum pump, my micron gauge will continue to fall if I'm far enough away and the system is large enough. That's how long it can take to equalize through that whole system. So those are some good practices. Once I've completed my vacuum, I've pulled down as far as I would need to go. I'm gonna isolate that, and I'm gonna watch what's called decay. I'm gonna watch how quickly I lose my vacuum, okay? And one of the misnomers that we have today as technicians is, I think that vacuum should just be right where I turn it off, should stay right there and hold. And if it doesn't, I got a leak. Well, the reality is today's equipment and techniques and the tools we have, we can actually see the system is not scientifically perfect for holding a vacuum. It's going to leak a tiny amount. And if you look at valve manufacturers, they'll all list the amount of leakage that's acceptable, right? In the practical world, there's none. For us, it's none. We don't have to add another 100 pounds of gas once a year because our valves leak the correct amount. It's way less than that, right? We've never had to worry about that in the past because we couldn't see it, right? If our gauge said 29 inches and it sat there at 29 inches, that was good, Today, my micron gauge is going to show me, that's 50, 51, 52, 53 microns, right? I can actually see that. So that means I've got to be able to distinguish between what's normal and what's a leak, okay? And that's one of the things we're going to talk about today when we actually do this test is take a look at a decay and determine, is that okay or not, all right?
Does anybody know what a micron is? What, a micron? A micron is a millionth of a meter of mercury column pressure. So when you talk to old timers and they're like, why do I need a micron gauge? It says 29.9 on my gauge. I'm like, you know what? I agree. I want you to measure off 5 feet for me. They're like, all right, well, give me a tape measure. I'm like, no, I want you to do it with your odometer in your truck. That's what we're doing when we're trying to measure vacuum with a regular gauge. It's not that it doesn't measure pressure. It just measures in a scale that's not useful at all for what we need to be measuring in vacuum. But that's also why, to what Matthew's saying, it may sound like crazy that we're saying every system leaks. Every system leaks. Every copper joint leaks at the molecular level. That's all we're saying. And a micron gauge is just so accurate that you're going to actually start to see that. But if you're doing a decay test and you're staying, again, you let it hold for 24 hours and you're staying under 1,000 microns, or it depends on the application, obviously. That's where that standard, it's a little bit of a moving target depending on the system and the internal size. But just know that it doesn't mean something's broken. It just means that you need to know what the standard is for what you're pulling.
So we're going to go ahead and kick this off. I'm going to do 2 things on this table. One is I'm going to pull a vacuum. I'm going to show you the system that we're using. This is the vacuum micron gauge that all the techs have access to. These are the tools that the techs have access to. As you can see labeled on my vacuum pump, it is actually one of the techs' tools that we're using. I'm going to set that up and get that system running, and then while we're doing that and letting it pull down, We'll go ahead and do a pressurization on a small piece of copper and demonstrate the proper process for that. Then we'll come back to the vacuum and see what's going on. One of the challenges to pulling a vacuum, we talk about, it's getting rid of moisture. That's really one of the big things. So just for fun, I said I was going to add some water. I really am going to add some water to this. And we're going to watch, because I can graph the way my vacuum pump runs, I can see that water boil off on the graph and see when it overcomes that. It'll be pretty neat. When we're done, we'll cut open that tube and see, is it dry, right? I'm going to go ahead and cap that while we got some water sitting in that. So let's talk about this just for a minute, my setup here. So this could be any size system, right? This could be my entire store. This could be a residential air conditioner making a loop, whatever.
So this vacuum pump could do a whole store?
Yeah.
Really? Okay.
Yeah. Now, it's a question of time, right?
Yeah, right.
It is a question of time, but this absolutely could pull down an entire store. Would I want to do that with a live store that's got groceries? Of course not, right? Now I've got a time issue, right? But if I've got all the time in the world, why not, right? This type of a system is for a service tech. This is a really convenient size for a technician to bring in. He's got an isolated compressor. He's got to make a repair. It'll pull that down very quickly, right? Rather than a store, okay? But I may do circuit, right, or two easily with something like this. Now, in my presentation, I was talking about the size of our hose. We've kind of figured out those 1/4-inch hoses. Once again, they'll do it, right? It's just a function of time. Well, it's a big change, right? A 1/4-inch tube doing the same amount of work, roughly 30 minutes versus 8 hours for 3/8, right? That's the difference, 30 minutes and 8 hours, ballpark. So we've figured out that, yeah, that's not a great way to go with the 1/4-inch. Now, that's assuming I've pulled my cores also, right? That was the other thing we discussed, is I got to take my cores out. All right, so I'm going to attach to one of my fittings, or 2 or 3, right? So if I'm hooking up on a rack, for instance, I'll have a bunch of different places I can connect. I got 4, why not use them, right? Use as many as you need. The pump itself could be rated somewhere, most modern pumps, somewhere around 6, maybe up to 8. A 1/4-inch hose with a Schrader can pull around 0.7, right? So I'm not using anywhere near the capacity of the vacuum pump itself. If I don't do something like I'm talking about, go to 3/8 hoses, pull the cores. If I want to try to get, if I've got a 7 and this one's an 8 CFM pump, if I'm going to try to pull all 8 of that, I'm not going to get that out of this either, right? So I'm going to go ahead and connect more hoses to try to pull all 8. Right? Why wouldn't I do that? When we're talking about pulling down an entire store, yeah, I'm definitely going to do that. In fact, I may need even more. So I may actually hard pipe my vacuum pump to the rack instead of running hoses, right? Might do that, depending on how big a system it is and how quickly I want to pull it down. Okay, so we've been talking about pulling our cores. What are we talking about? Well, you guys know, we got caps that we can pull a core out of. But I'm talking about using a tool to do that, and the reason is not necessarily because it's under pressure when I'm starting, maybe when I'm done, right? But this is that valve I was talking about in the presentation. I want to be able to isolate my vacuum with a vacuum-rated valve, okay? These new cores, and I say new, probably the last 15 years, are rated for vacuums. Okay, so this is probably a superior valve than my manifold set, unless my manifold set's pretty new also and in really good shape. Okay, so when I'm going to take this guy, I'm going to pull my core out, which I've already done on this particular one. I'm going to set my tool. Now, I do have a Schrader on the side of this guy that I could use if I needed to, for service right here. For instance, if I'm going to charge the system from a vacuum, I pull a hard vacuum and I want to add refrigerant. Well, I didn't use my manifolds. How am I going to do that? Well, I could connect right here. Okay, that is an advantage of having that. But isolating my vacuum is what we're talking about. So that's why I'm going to use that valve. Now, you guys know I just put water inside this thing, so I am going to be a little cognizant of keeping that out of my pump and my micron gauge as we go. That's why I turned that valve off before I connected it. Okay, so the other thing that I told you we want to do is connect our micron gauge on as far away from our vacuum pump as we can. okay? So I'm gonna put it out here on the end because I don't have much piping, right? But this is representing a far point on my rack, right? A case inside the store, maybe my farthest run, right? And I'm gonna turn on my vacuum pump. Now, modern micron gauges do have some type of Bluetooth technology. This is not required for pulling a good vacuum, but it is a very powerful tool that we can use for a lot of things. One of the questions that came up in the Q&A is, how do we report what our vacuum look like? Well, this is the device that'll do that. It's gonna send that to my phone because my phone's connected to it. So when I turn on my Bluetooth, fire it up here, and I've got it, right? So I've got a picture of my micron. And right now, it's not great. Okay, I'm in atmosphere, right? So it's showing me that. Well, I can record this whole pull down process and have a running video of this thing. It will also record the graph, right? So I can see what's happening in my actual microns that is pulling down. This part is a tool that is new. And when I say new, it's new to modern technicians. My old man and me growing up did not have this tool. This tool is a visual representation of what's going on with my vacuum. So I can see when I hit water, it will show up on the graph, right? I can see when the water's gone. I'll see that on my graph, right? In the old days, what am I seeing? I'm seeing a gauge at, a meter at 27.8, 27.9, 20. I don't know what that means, right? This is going to be really obvious, okay? Then the second thing that's going to happen is when I get done and I shut this thing off and I start watching my decay. That's when the questions start in the technician's mind. He sees that number rising, right? Is that too fast? Do I have a leak? Or is that normal? How do I know, right? My graph is going to give me a nice physical representation of what normal looks like and what a leak looks like. I don't have to guess anymore, right? So that's a really powerful piece. Okay, so we talked about our gas ballast a little bit. The idea behind the gas ballast, once again, I'm not going to go super deep into this, but the concept here is I'm pulling water out of my system, right? I'm boiling it by creating a vacuum and lowering its boiling temperature. Well, when it leaves the pump and it's exhausting, it's going back to atmosphere. It's going to condense. It's going to come right back. It's going to be water again, right? Well, I don't want that to happen inside my oil for my pump. That will contaminate my oil. All right, so the concept between the gas ballast is I'm going to open a system that allows a little bit of air to be injected right in that exhaust that prevents that water from condensing. Now, what's the cost? Why don't I run like that all the time? Well, one, I'm going to get a lot of smoke coming out of this guy, right? When I do that, I'm going to have some oil leaving the device in a mist, right? So I don't want to do that too much, or I could fill up my room with oil, depending where I'm doing this, or I could run out of oil for my pump. So I don't want to do that. And then the second is it's not quite as efficient, still really efficient, but I'm probably not going to get that 50 micron, that really low level vacuum if I've got my ballast open. So what I'm going to do is I'm going to leave it open long enough to clear all that water, get that out of there, and then when I start that final pull down, I'll close that ballast off, get the whole efficiency of my vacuum pump as I pull the rest of the way down. That's the concept behind that. Go ahead and fire my vacuum pump up. This particular one is going to give me a visual indicator my ballast is open. That's what it's doing. Most vacuum pumps don't do that. It is kind of cool. But as that's going, right now I'm pulling a vacuum to here. I'm not going any farther than that, right? So my system is not open to my vacuum pump yet. My micron gauge is still showing me atmospheric pressure as I'd expect, right? This is how we would do this. Now, once our piping, however many systems we have, are purged, we've got all the air out of them, we're gonna start opening up the system and adding that load, as it were, to our vacuum pump. In this case, it's just one valve, and that is going to start pulling down. I'm gonna leave that sit for a second. More than a second, right? So let's see what's going on over here. This guy says I'm all the way down to 165 microns. Holy crap, right? Now, let's keep in mind, it's a pretty small piece of pipe, but also keep in mind that I shot it with 30 cc's of water, right? That's pretty impressive. All right, so this graph is really dramatic. Most of my grocery stores, this is gonna be much more stretched out, right? This is just because it's so small, okay? But what I can see is, I can see this line pulled right down, and then it stumbled, right? You see where it was just yanking the stew out of this, and all of a sudden, uh-oh, and it started rising, right? And then it recovered again and pulled the rest of the way down, right? That's that little tick that I see there instead of a nice smooth line, okay?
I'm guessing that's water.
So I hit my water.
Hey, I guess
I hit liquid water at that point, and I couldn't pull a vacuum, right? What happened was, the reason it went back up is because I started boiling the water into vapor. I was adding gas to the system. My pressure went up, right? Until I evacuated it. So my water's gone. I can see that, right? Water's gone. Now I'm going to do my final vacuum, okay? I've closed my gas ballast, and I'm really digging in now, okay? Now, the gains that I'm going to make at this point are really slow, right? I made huge gains getting down to 168 microns, right? To get from 168 to 50 may take a couple hours, even on this small piece of pipe, okay? So here's where my gains get really, really slow, and this is where we've got to decide what's good enough, okay? The spec of our customer often is going to tell us 500 microns, 200 microns, something along those lines. That's what we're going to try to achieve. I'm at 167 now. If my spec was 200 microns, would this be good enough? Technically it would. Realistically, as a service technician, I'm going to try to get all of the water out of this I possibly can, right? What I'm actually probably going to do, I'm probably actually going to close that off, let it sit for a few minutes, right? A whole rack, a few hours, right? I'm going to let it stabilize, let everything, any little pockets of water in there, boil off, all that, let all that happen, and then I'm going to open it back up and I'm going to pull it down again, okay? Is that required? No, right? But is that a best practice? It is. And it's a leftover from the old days of triple evac, right? That's what we all learned in school. We're going to pull it down 3 times. Well, we're going to kind of do the same thing. The difference is we're not going to break it. We're not going to break our vacuum with refrigerant, right? We're just going to let it stabilize and then pull it down a little bit more. This is 100% flexible on my situation, right? If I'm a service tech, I am not triple evacing anything, right? The other challenge is it's probably tied to a ball valve on a live rack, and I'm pulling some refrigerant through the ball valve, right? So I'm not even going to see 200. That's why no customer specs 200 microns on a live system, right? Because you're going to pull right through the ball valve, okay? So that's not going to happen, right? But if I'm building a new store, why wouldn't I do that, right? One thing I'm going to point out here, I told you I'd show you a graph of what a leak looks like, right? I got one right now, okay? Now, I don't really have a leak. Really what I have is I didn't pull down far enough, so I still got some moisture in there. But you see, when I hit that bottom and then my line came up with a really hard line, right? It's a straight up line. It looks almost like a rectangle, okay? That is my indication that I'm not okay, all right? If I see that when I turn off my vacuum pump, all right, I've got a leak or I didn't run long enough, right? That's what it looks like. If I get a nice, instead of that straight up line, if I get this kind of a gradual line that goes off to the side, nice and slow, that's what normal decay looks like. I can tell this thing that I'm done, and we'll see what it thinks about my decay. All right, so in the interest of time, we failed our decay test, but we want to see, did we dry it out? All right, so we got down to 168 microns for what, 5 minutes, maybe 10, not very long, right? But we got through that hump, okay? So we expect the majority of our moisture, anything we can detect as human beings, probably is gone. There's probably are some molecules floating around in there of water, right? That's why I'm failing my decay test. Are we going to be able to detect that? Probably not, right? I don't know. Let's see. It'd be kind of fun. All right, so I'm going to shut off my vacuum pump. I'm already closed here. I'm going to break my vacuum. Now, the way I would do this in the real world is with refrigerant, right? If I've passed all of my tests, everything's good, I've got my vacuum, what am I going to do now? I'm going to introduce refrigerant, and I'm going to put a positive charge on the system so I can't pull any air or moisture back into it. It's now positive, and I'm ready to start charging for my startup process. That's what I would normally do, okay? Today, we're just going to blow the vacuum right off of it, just opening some things up. All right. My shredder's not in the end, so I have no pressure, okay? But I want to see what's going on in here. Pass that around. We got any water inside? You guys saw how much water I put in that, right? Pass that around.